Hello and welcome to part 3 of our exam walkthrough for 91267 probability. Studies have found some links between EV ownership and the installation of a home solar system. An online survey was taken in the USA of EV owners, plug-in hybrid vehicle owners, or PHEVs, and other interested people who owned non-electric vehicles during a 3-month period in 2018. The results are summarized in the table below. And we're going to use this table to answer parts 1 to 4. So the first question is, what proportion of survey respondents owned an EV or a PHEV? So with these questions, it's all in the wording. So it's what proportion of survey respondents. So it hasn't narrowed it down at all. So that's out of all of the respondents. So that's 2,000 people. So probability of EV or plug-in hybrid, PHEV. So it's going to be out of 2,000. And it's what proportion of all of the survey respondents owned an EV or PHEV. So there were 286 owned EVs and 155 owned PHEVs. So we'll go 286 plus 155 at the top. So we're adding those because it's one or the other, so that increases the probability. And that gives us an answer of 0.2205. And that's the answer. That is it. So that is an achieved question. Part 2 now. Which type of vehicle owner, so EV, PHEV, or non-electric, in the USA is more likely to have a home solar system according to these survey results? So more likely to have a home solar system given what type of vehicle they own. So for the EVs, so let's scroll up and have a look, shall we? So for the EVs, out of the 286 EV owners, 112 have solar systems. So that probability would be 112 out of 286. For plug-in hybrids, 45 out of 155. And for non-electrics, 214 out of 1,559. So let's work out those probabilities. So for EV owners, it's 112 out of 286, which is 0.3916. For PHEVs, it is 45 out of 155, which is 0.2903. And for non-electric, it is 214 out of 1,559. And that is 0.1372. So remember, the question was, which type of vehicle owner is more likely to have a home solar system? Well, so that we're looking for the highest number here. Well, that is EV owners, because that portion is 0.39, or about 39% of the EV owners had home solar systems. So which type of vehicle owner is more likely? EV owners are most likely to have a home solar system. And that is a merit question. So for achieved, you have worked out one correct probability out of those three, and for merit, all three probabilities correct with a conclusion. So again, any one of these three numbers for achieved, and then full answer for merit. Okay, on to the next question. There were 52,439 home solar systems installed in New Zealand as of August 2023. In case you're wondering, that was a real number. Use the results from the USA study in Table 1, which were made up numbers, to estimate how many of the home solar system owners in New Zealand also owned EVs. Okay, so what we need to do is use the information from that table that we had for the USA owners and try and apply that to New Zealand with that number that we've been given. So in the USA, so based on that data that we were given, the probability that an owner who had a solar system owned an EV was 112 out of 371. So if we just scroll back up, let's get rid of all these. So out of the 371 who had home solar systems, 112 had EVs. So that is why the probability is 112 out of 371, which is 0.3019. So that's about 30%, 30.19% of the people that had solar systems had an EV. So if we apply that to New Zealand, this is an expected value question. So with an expected value question, you work out the expected value by multiplying the probability of your outcome that you're interested in happening by a number that you are given. So we're going to multiply this by this. So NZ, so we're going to do 0.3019 times by 52,439. And that gives an answer of 15,831.3341. It's got to be a whole number, so we will round that to 15,831. That would be how many people we would expect to have an EV based on those proportions. So that is achieved by itself. In combination with part 4, this can be a merit. So we have to get part 4 correct as well. And part 4 is to give at least one statistical reason why using table 1, so that information recorded in the USA, to do part 3 that we just did may not lead to a valid estimate in this case. So the main reason is it's from a different country, and different countries are different. The USA, obviously, not the same country as New Zealand. It's different. It's different in lots of ways, which include, so obviously America is a very varied country in terms of climate. So, there'll be places where you maybe wouldn't consider having solar panels because of the climate. And there's other places you might do. There could be incentives in the US for installing solar panels. At the time of recording this, there's not in New Zealand in terms of sort of subsidies. And all things like that will affect, and the cost of installing them could be different there as well. Lots of potential different things that would mean that quite possibly these proportions would not be the same in New Zealand as they would be in the USA. And not just for the solar system, but also for electric vehicles as well. It's a very different landscape. And that could mean that probability, so 30% of people that have home solar systems having EVs, may not be true in New Zealand. It could be higher, it could be lower. So it could be technology, price of EVs or solar, availability, again, of EVs or solar systems, etc. Anything along those lines would be an acceptable answer. Again, incentives or lack of for EVs or for solar systems being installed or purchased. Differences in electricity prices as well, which again will vary depending. It varies within New Zealand. It varies within the USA as well. That would have an effect. That if electricity is more expensive, that's more of an incentive to install a home solar system. Prices of fuel as well, for the likelihood of buying an EV. The more expensive petrol or diesel are, the more attractive an electric vehicle becomes. Again, you only really need one of those points. Anything along those lines, something sort of explaining New Zealand and the USA are different, is an acceptable answer. Also, the sampling method is another angle that you can take on this. So if we sort of scroll back up and reread the information right from the beginning, this was an online survey during a 3-month period of 2018. So we are now in 2023, so this was 5 years ago. Things have changed since then as well. So that could have an effect. Like 5 years is quite a long time, especially for sort of a fairly new technology in terms of electric vehicles. That could have an effect. So, like, would this data still be the same for America now? But also the sort of fact it's an online survey. Nothing wrong with it specifically being online, but it's sort of an opt-in survey, if you like. So someone's got to go and do the survey themselves. It's so that means you sort of have maybe a specific type of person, someone who's perhaps interested in electric vehicles or in solar power, clean energy, whatever. So that's probably for those interested, because someone's gone out and sort of sort out this survey, if you like. The sample size is pretty good, of sort of 2,000 people. That's a pretty big sample, but is that 2,000 representative of the wider USA population? Not necessarily. Maybe there's a bias towards owners of EVs or home solar systems, so maybe those proportions are higher than they are in the wider population. So again, this combined with the previous one is a merit. So you sort of get, the first one by itself was achieved, merit, the correct answer there, and correctly rounded to a whole number, and then at least one valid reason why the estimate may not be appropriate. So really, if you sort of say any one of these things here, that's enough. You don't need all of this stuff. So that's a merit. Okay, on to the next one. A similar survey was conducted in Europe at the same time, and some of the results are shown below. Complete the table above and use it to find the probability that a randomly selected respondent whose vehicle was a PHEV had a home solar system. So first what we need to do is we need to fill out this table. We've got enough information here where we can do that. So if I start with this one here, so home solar system, well, the other two in this row are complete. So this missing one plus 346 has to make 615. So if we do 615 take away 346, that will give us this answer, which is 269. Similar thing for this box here. 118 take away 47 is 71. If we now look in the home solar system column, we can do 438, the total, take away 47 and take away 269, and that will give us this missing number here, which is 122. In the total, row, we could do this one, doing 1,500 take away 438, which is 1,062. If we look at the total column at the end now, we could have done this one beforehand, doesn't matter. So this missing box will be 1,500 take away 615 take away 118, which is 767, which makes this one here 645. And then just double check like everything works out before we move on, which it does. So that we can answer the question now. Find the probability a randomly selected respondent whose vehicle was a PHEV had a home solar system. So we've been told they owned a plug-in hybrid electric vehicle. So what that means is we're only interested in these numbers here. We don't care about EV owners or non-electric vehicle owners for this question. We've been told they have a PHEV, so this is going to be out of 118. So they had a home solar system. Okay, that's 47. So that probability is going to be 47 out of 118. You can convert this into a decimal if you want to, but it's not necessary. It's fine to leave the answer as a fraction. And that is an achieved question. So for this one, you just have to have the probability correct. Whether it's a fraction or it's a decimal, so long as you've got that, then you're okay. Okay, on to the next one. A newspaper article quoted some of the findings from the two studies shown in Table 1 and Table 2. And it is claimed that, so there's a couple of claims. In the USA, EV owners are 3 times as likely to have a home solar system as non-electric vehicle owners. And in Europe, we'll maybe do this in a different color just to make it stand out. In Europe, EV owners are only 2.75 times as likely to have a home solar system compared to non-electric vehicle owners. So, sorry, plug-in hybrid vehicle owners, we're not interested in you for this question. We're comparing EV owners to non-electric vehicle owners. Can these claims be supported? This type of question, very common in NCEA exams. A claim is made. Is it true? Okay, well, we need to work out some probabilities to see if this claim can be true. So let's start with the USA. So in the USA, the probability that an EV owner has solar is 112 out of 289. So this information here is from the it'll be 286, won't it? Because there are 286 EV owners. Better get that correct. And 112 of those 286 have a home solar system. So that gives, if we turn that into a decimal, 0.3916. Don't have to convert this into a decimal, but it will be helpful for the next step of the question where we try and compare the probabilities. It's a bit easier if they're decimals, but not essential. Okay, so that's the probability an EV owner has solar. So we want to compare that to the probability that a non-electric vehicle owner has solar. So the probability that a non-electric owner has solar. Okay, so non-electric, there was 1,559 of them, and 214 had solar. So that probability is 214 out of 1,559. As a decimal, that is 0.13 0.73. So what we need to do now is something called a relative risk calculation. So what this does is it works out sort of how many times more likely one thing is than the other. So it makes sense to do it this way. So 0.3916 over 0.1373. So this will work out how many times more likely is it that an EV owner has solar than a non-electric owner has solar. And the answer to this is 2.85 times as likely. So that's not quite the same. It's kind of close. You can round that up to 3, but it's not quite the same as the claimed 3 times. So you could probably argue that either way. That, okay, it's kind of close, or, well, that's not 3 times, so that claim is false. Before we reach our conclusions, let's do Europe. Because we need to evaluate both of the claims. We'll just do them both at the same time. Not essential. You could write your evaluation of the claim for the USA, then move on to Europe. It doesn't matter, as long as we've done it. Okay, so we're going to do a very similar thing, but for the numbers for Europe now. So probability that an EV owner has solar, first of all. So for Europe, this is going to be 269 out of 615. So if we just scroll back up to this information. So EV owners, there's 615 of those, and out of that 615, 269 had home solar systems. Then for the non-EV owners, well, there was non-electric vehicles, there were 767, and 122 of those had a home solar system. So we'll be using that in the next calculation. So 269 out of 615, and that is a probability of 0.4374. And then for the probability of a non-electric owner, the R kind of got lost there, didn't it? Should be electric, not electric. Electric owner has solar. That is going to be 122 out of 767. So 0.1591. So same as we did for the USA, we'll do a relative risk calculation. So same as before. The risk of, or likelihood, EV owner, how many times more likely is it that an EV owner has solar than non-electric owner? And that comes out at 2.75 times as likely. Okay, well, let's evaluate these claims. So what were the claims? In the USA, EV owners are 3 times as likely. In Europe, they're 2.75 times as likely. Well, we got 2.75 for Europe, so that's exactly correct. So that is a valid claim. For the USA, it's a little bit off. It's not quite 3 because it's 2.85 times. So in the art, they will actually allow it either way. Either the argument that, well, 2.85 is pretty close to 3, so that's valid, or 2.85 is not 3, so that is not valid. I'm going to use that argument. I think that one makes most sense. So for the USA, the relative risk was 2.85, not 3. So that is not valid. So again, I'm making that argument that they are not exactly the same, so that is not valid. For Europe, the relative risk was 2.75, exactly the same as the claim, so that is valid. Exactly the same as the claim, so that is valid. Now, for both of them, you could sort of also make an argument about the survey method and whether you feel like the survey method is valid. Well, both of them are fairly large. It was 2,000 for the USA and 1,500 for Europe. Those are pretty big surveys. So that's good. As we mentioned in that previous question, an online survey is not necessarily representative because, again, it's kind of opt-in. This is something called participation bias, where those who participate in the survey, because they've sort of opted into it, they have chosen to do it, they might be more likely to have an EV or have solar because it's something they're interested in, so they've gone and done the survey. So that is something you can mention as well. Maybe even like for Europe, okay, yes, it is 2.75 times, but is that true for the population? So these points here are other things that you can mention in terms of the validity, why it may not be appropriate. You can say either one of those things, so they kind of contradict it, right? Good sample size, you're saying, well, that makes it more likely to be valid. Participation bias from the surveying method, well, maybe that makes it not. Maybe that makes it not relevant. So this is an excellence question. So for achieved, 1 European probability correct. For merit, 1 relative risk obtained correctly, either for Europe or America. So 1 European probability correct is achieved. Getting the relative risk for either country merit. For excellence, there's 2 excellence marks available here. For 1 excellence mark, calculating both relative risks correctly and interprets them and makes a decision on the validity of the claims. For the second one, both relative risks calculated and interpreted, and validity of the claims is justified, either way, with at least 1 valid connection to the context of these surveys. So that would be any of this for excellence, and for what's called T2 to get all of that. Okay, so that is that question done, and that is the end of the paper. So we can finish there. Thank you for watching.